So an important characteristic of the simple harmonic motion is that it is related to circular motion. Imagine that you have a turntable, and then you have a ball fixed here on the turntable, and you have light coming from some projector. And you look at the shadow here, and what you're going to see is that this shadow moves back and forth, and this motion here is going to be a harmonic motion, a simple harmonic motion. Let's look at some simulations to understand this better. This is our turntable here, right? And this is the ball attached, and this is the shadow. And on top, we have a spring attached to a mass attached to a spring that is also doing a harmonic motion. Let's look at the simulation and see what happens. Right there, they both start from zero here, and then they go. You can see the shadow is moving exactly with the same motion as the spring, and this is a harmonic motion. Another simulation that shows the same effect is this one here. Here you have this particle moving in a circular motion, and this red particle here is just the y component of the position of this blue particle. So let's look at this y component as a function of time. And then you can see right there that the red point, which is the y component of the position of the blue particle, is describing a simple harmonic motion. An important idea attached to this is the idea of phase constant. Sometimes the motion doesn't start right here in zero, but it starts somewhere else, or you start looking at the motion at some other point other than zero. And then this extra angle here, right? This extra angle has a name. We call that the phase constant, and we measure that in radians. It is the point that gives you your initial condition where you start looking at the motion or where the motion starts. So you can write then your harmonic motion as a cosine of omega t plus the phase constant. If this is zero, then you're starting right here. But say this is something else, then you're going to start at some different point. Let's look at some values for that. Here we have a phase constant of pi over 3 that is 60 degrees, right? So you're starting over here. That is your initial condition. You would be starting somewhere right here. Here we have a initial condition of minus pi over 3, that is minus 60 degrees. So you would be starting somewhere right here, right? And then finally you have a phase constant of pi, which is pi is all this angle here, 180 degrees, so you will be starting somewhere here. So that is the idea of a phase constant that and is an extra quantity that we need to describe harmonic motion.